So to solve this problem, let's look at what the chemist doesn't want to happen, right? So the chemist is going to leave this solution in the chemistry lab for a decent amount of time, overnight, right? And the chemist still wants there to be this carbonate in the solution afterwards. So what could go wrong here? Well, notice if we allow, no matter what happens, this reaction is going to happen. No matter what pH we use, the sodium carbonate is going to dissolve. We're going to have sodium and carbonate, right? This carbonate is the important part, though. We want the carbonate. And the problem is that the chemist, the scientist, wants to use the carbonate in their experiment. However, we need to notice here that the carbonate will react with H plus ions, right, to make this carbonic acid. And then by itself, doesn't need anything else. This carbonic acid is going to make H2O and CO2. Now, this is bad, right, because we want this. We don't want this to be transformed into this, and we especially don't want it to be transformed into this, because notice, this is carbon dioxide. This is a gas, right? So if that happens, that carbon dioxide is going to leave the system, and now the carbon itself is totally gone. You can't have carbonate without carbon. So we don't want this reaction to happen, because if this reaction happens, this reaction is going to happen. So we want to minimize this reaction right here, right? So let's think about how reactions really happen. When we have two molecules that are going to react, right? I'll just draw them as balls. Obviously, they are more complicated than that. We have a bunch of these molecules in solution, and let's call them molecule A, molecule B. And molecule B will be colored in, and molecule A will be not. So they're floating around in solution, and since the solution's obviously got some temperature, the molecules are moving, right? And so they're all moving, some direction, some faster than others. Obviously, it's very chaotic, and the reaction occurs when two of the appropriate molecules collide with enough energy. So right here, this molecule and this molecule might collide with enough energy to cause the reaction to happen, right? Because they're both moving relatively quickly and they're going to hit each other. So what would cause the rate of the reaction to increase or decrease? Because we want to minimize the rate of the reaction. That's what we're looking at. So let's think about this. If we have a higher concentration of particle B or of molecule B, the colored in one, how is that going to affect the rate of this reaction? Well, if we have a higher frequency of these in the solution, that means that more collisions are going to occur between molecule B and molecule A because there's just more opportunities, right? There's more molecule B's floating around, so it's more likely they're going to hit molecule A with enough kinetic energy to cause a reaction. And the same with molecule A. If we have more molecule A, it's more likely we're going to have a collision. So what we can ascertain from this is that higher concentration of reactants causes an increase in the concentration. Causes reactants causes an increase of the rate of the reaction, meaning how fast the reaction proceeds. So now we need to think about how to minimize the concentration of reactants because we want to minimize the rates. We want to minimize the concentration of reactants. Well, we're going to have the same amount of carbonate either way because we're dissolving it in a solution and we've got a set amount of sodium carbonate. However, this other reactant, H+, is the important one here because the question asks about pH, and what is pH? Well, pH is a measure of how much H+ there is, right? And this might seem, mathematical or whatever, but what we really need to know is that when pH goes up, H+, the concentration of H+, or of hydrogen plus ions, goes down. And similarly, if pH goes down, then the concentration of H+ ions goes up. Why is this important? Well, the question asks about what pH we'd want to use, a high or a low pH. And we want to minimize the rate of the reaction, and that means that we want to minimize the concentration of the reactants. Here, this really just means 2H+, or just H+, right? So if we want to minimize H+, we should use a higher pH, or a more basic or alkaline solution, which means that this reaction will proceed less readily, it'll happen less at a slower rate, and that means that this reaction will happen less or at a slower rate.